Hi guys, welcome to our note 7.2 volume, the disk method. So our objective this lesson is to use integration to find the volume of a solid of revolution. So that means we create a solid by revolving something around an axis of revolution. So we're using actual disks for the disk method. So a disk is just another word for a cylinder, right? And a cylinder's volume is just a bunch of circles, pi r squared, stacked h high. So a disk is just a cylinder with a volume of pi r squared multiplied by h. So let's look at a couple examples of how we set up volume here. So let's say we have a linear function f of x. Obviously, it's not always going to be linear. If I rotate that line across around the x-axis, it creates this 3D shape. What I can do is put in infinitely many disks to fill up this volume. Now, if I look at the disk, the radius of my disk is the height of my function, f of x. And the height of my disk, since it's turned on its side, is a very small change in x, or dx. Especially if I put infinitely many of them in here, it'll be insignificant. So the volume over any interval a to b is the integral from a to b of pi r squared h, pi f of x squared times dx. Here's the same function, f of x, but I've changed it to be a function of y because now I've rotated it about the y-axis to create this shape. Now I have a horizontal disk. The height of that disk is dy, and the radius of this disk is my function of y. So the volume of this shape over an interval of a to b is pi times my radius squared times my height. Pi times f of y squared dy. So whenever you create a solid by revolving around an axis or line, we can use the disk method and use a Riemann sum of infinitely many disks to find the overall volume.